So welcome really to this latest GCSE revision video on AQA topic test on the higher syllabus, looking at further quadratics, rearranging formulae and identities. Now there will be a copy of the questions in the description below for you to download and have a go at before watching this video as we go through the answers. So let's get started on this AQA topic test on the higher syllabus, looking at further quadratics, rearranging the formulae and identities. So looking at question 1, it's related to functions, and it says that the function of x, or f of x, is equal to 2x plus 3, and the g of x is equal to x squared. It says circle the expression that represents the inverse function of f of x. Now for this, what we need to do is, well again, just a quick reminder how we work out inverse functions. That if f of x is equal to 2x plus 3, then what we want to do is replace the f of x with y, and then make x the subject. So I'm going to have y minus 3 equals 2x, and then y minus 3 over 2 equals x, and then replace the x with the inverse function f of x. So what I'm looking, replace the x with y, well, the y with x rather, and then what we're looking for is this. So we're looking for x minus 3 over 2, which is our third option. For question 1b, it says circle the expression that represents fg of x. So what I'm doing is I'm going to replace x in f of x with this expression. So what I end up with is 2 and then x squared plus 3, which simplified gives me 2x squared plus 3. And which expression is that? Well, that's going to be number 2. Now looking at question 2, it says the shape is made from a large semicircle radius capital R and a small semicircle radius little r, joined as shown. Work out the expression for the perimeter of the shape. So what I need to do is see how many of these sections I've actually got. Now here I've got this blue section, which is half the circumference of the circle. So this is going to be 2 pi capital R over 2, which is just pi r. So I can replace this with just pi capital R. And what I'm doing is I'm just going to rub this out. Then with regards to this section here, well that's just going to be little r. And then this section here is going to be very similar to the large rectangle. So that's going to be 2 pi little r if it was a full circle, but it's a semicircle. So I divide that, cancel the 2's, leaving me with just pi r. So this little green section is pi r. Again, let me just quickly rub that out. Now, typically in the exam, you wouldn't rub out what I'm rubbing out. And then for this section here, that's going to be capital R. Now, the one thing that I reckon a lot of students will miss out is this little section here. Now, this little section, if I looked at all of it, it would be capital R, and this dotted line represents little r. So that then represents that. Now, to work out the perimeter, what I need to do is add up each of those sections up. So what I've got is I've got that P equals, and then pi capital R plus R minus R plus pi R plus R. Now from this, what I could then do is kind of simplify, and let's just expanding, we can cancel things out. So looking at this, and again I'm going to leave my answers there, but if I just get rid of this, let me just write down what I've got. Is that this cancels with this. I've ended up with R and, well, 2R. So that this then becomes 2R. So the three components I've got then are going to be that P equals pi capital R plus 2 capital R, should be capital R, plus pi little r. Moving on to question 3, it says simplifying, and we've got this. Now again, with indices, remember we need to raise everything to the power of 3. So 3 to the power of 3 is 27. X squared to the power of 3, well I multiply the powers, so that becomes x to the power 6. And then y to the power of 3 is just y3. Leave that as my final answer. Then moving on to question 4, we've got triple bracket expansion. So again, it can be done in similar ways. So what I'm going to look at first is I'm going to expand, oh, don't know why I've crossed that out. what I'm going to do is I'm going to expand these two things out first. Now if I do this on the side, so what I've got is I've got 2x plus 1, 3x plus 2. So again, 6x squared plus 4x plus 3x plus 2 gives me 6x squared plus 7x plus 2. So what I've got is I've got x minus 5, and then I've got 6x squared plus 7x plus 2. Then expanding first bracket out, and what I end up with is 6x cubed plus 7x squared plus 2x, and then minus 30x squared minus 35x minus 10. And then joining all of those things together, so I've got 6x cubed, then I've got 7x squared minus 30x squared is going to give me minus 23x squared. I've got 2x squared minus 35x is going to give me, minus plus 2x minus 35x is going to give me minus 33x. And I've just got the single 10, minus 10, and there is my final answer. Question 5, it says, which of the following has been wrongly written as an identity? Circle your answer. Now, identity is where algebraically the left-hand side is the same as the right-hand side. Typically, it involves brackets, or could be written in terms where it's factorized and one side's been expanded, but there you go. Now, in terms of the correct answer, I can see this straight away is going to be this option here. And the reason for this is because when I end up expanding this out with minus a squared, so minus a times minus a, that's going to give me a positive a squared, which here you can see we've got a negative a squared. That's where I can tell straight away that that's wrong. Question 6, it says factorize fully. So looking at the numbers, I want to take out the biggest number that appears in both the 18 and goes into 32, and that is going to be 2. And then I've got a, and now I haven't, so I've just got the 2. So then from this, what I've then got is, write it here, so taking 2 out, I get 9a squared minus 16. Now, one thing I notice here is that this here represents a difference of 2 squares. And so when I've got this, I've got 2, and then writing this as a difference of 2 squares, I'm going to end up with 3a, 4, and a 4, a plus and a minus, and is my final answer. For question 7, we've got to factorize this quite complex quadratic formula, and again, expression rather. Now again, you could do it by just by guessing and knowing it just by inspection, or you could use the magic number method, which is what I'm going to go through now. So here I've got 12 times 3, which is 36. Well, it's actually minus 36. So what I'm looking for is two numbers that multiply to give me minus 36, but added together give me minus 5. And so looking at the two numbers, I'm going to go for 9 and 4. 9 and 4, and I'm going to be going for minus 9 and positive 4. So in terms of looking at the expansion, I've got 12x squared minus 9x. Well, let's go for the 4. They didn't really make a difference. So plus 4x minus 9x minus 3. So then factorising the pairs, I end up with 4x, and I've got 3x plus 1 minus, and then I've got 3, and if I factorise the pairs here, I've got 3x plus 1, and there we go. And then what I've then got is one bracket is going to be 4x minus 3, the other bracket is 3x plus 1. And moving on to question 8, it says rearrange the formula to make x a subject. So again, here you can see we've got two x's I can see. What I'm going to do is first of all put that in brackets and then take that over to the side. So what I've got is I've got y lots of 4x plus 5 equals 2x minus 1. From this, what I then want to do is expand the brackets. So I've got 4xy plus 5y equals 2x minus 1. I then want to take this 2x to the other side and take the 5 over to this side. What I end up with then is make a bit more room. So I'll just write that out again. And so take the 2x over to this side. So I've got 4xy minus 2x plus 5y equals minus 1. Then take the 5y over to the side. So I've got 4xy minus 2x equals minus 1 minus 5y, and then factorize this. So I've got x, and then I've got. Now I'm not gonna write 2x. I'm going to factorize it fully because I just want x by itself. So here I've got 4y minus 2 equals minus 1 minus 5y, and then take this bracket over to the side. So I've got x equals minus 1 minus 5y over 4y minus 2, and that gives me my final answer. So x equals minus 1 minus 5y over 4y minus 2. And then finally, moving to our next question, what we should have is, looking at question 9, it says that the algebraic fraction ax squared plus bx plus c over dx squared minus 4 will simplify to give you 2x plus 3 over 3x plus 2. And we want to work out the values of a, b, c and d. Now, one thing we notice is that this here looks like a difference of 2 squares. So it looks like a dot. Now, if this is one part of the brackets, then the second bracket has got to be the same denominator but reversing the sign. So what I'm going to end up with is, and what seems to have happened, is that that answer has been multiplied by 3x minus 2 over 3x minus 2. So what I've then got is 2x plus 3 and then 3x minus 2 over 3x plus 2 over 3x minus 2. Now if I then go on to expand both of those brackets, then what I end up with is 6x squared minus 4x plus 9x minus 6. And on this I'm going to end up with 9x squared minus 6x plus 6x minus 4. And then if I then go on to simplify each of those sides, I end up with 6x squared plus 5x minus 6 over 9x squared minus 4. Now from this, what I can then do is compare the coefficients from what I can see here. So here you can see that my d is 9. I can see that my a is going to be 6. I can see that my b is going to be 5, and c is going to be minus 6. And that is the last bit of this topic test.